Welcome to the pre-calculus notes for Unit 2, Lesson 3 on polynomial division using the area model. Many of you may have seen the area model when we use it for multiplication, but it is also a very effective way to show the division of two polynomials, or we could call it polynomial deconstruction by factoring. So diving right in, it says the area model is a geometric way of representing polynomial division. So we begin with this idea that we have a box setup which represents our dividend, that thing that we are dividing, and our divisor. So the first thing that I'm going to do is I'm going to write my divisor along the side of my boxes. So I'm going to put x, and I'm going to put plus 2 down the left-hand side. Now, inside here you will notice there are 6 boxes, but when I look at my dividend, there are only 4 terms. Now, the reason for that is because this 5x squared will actually be the sum of these 2 boxes along this diagonal. This term of 5x will be the sum of these 2 terms along this diagonal. We'll get more into that in a second, but let me begin by writing my first term in the top left-hand corner, which is x cubed, and my constant term in the bottom right corner, which is negative 2. Now, at this point, I'm going to be doing a series of small divisions and multiplications to figure out what goes in the rest of these boxes. So the very first thing I'm going to look at is I'm going to say this x cubed term is the product of x and something. Well, I know that x times x squared will give me x cubed, so I'm going to write my x squared there. Now, knowing that this is just multiplication, x squared times x gives me x cubed, x squared times 2 gives me 2x squared. As I said, the terms along this diagonal are going to add up to 5x squared, so if this is 2x squared, this other box must be 3x squared, because 3x squared plus 2x squared is 5x squared. Now I'm back to the original problem of what times x gives me 3x squared. Well, I know that that's a positive 3x. I'm going to put the plus sign there. So 3x times x is 3x squared. 3x times 2 is 6x. Again, we look at the idea that these 2 terms must add together to give me 5x. So 6x and negative 1x will give me 5x, because 6x minus 1x is 5x. And we begin again. X times what gives me negative 1x? That's negative 1. So negative 1 times x is negative 1x. Negative 1 times 2 is negative 2. That checks out. So when I go to write my quotient, I'm only going to write what's up here across the top. So I'm going to say that my quotient is x squared plus 3x minus 1. This problem worked out relatively well because there was no remainder. Our polynomials divided evenly. But sometimes we deal with polynomial division that leaves us with a remainder. So I am going to begin this problem the same way, but it will finish a little bit different. So I'm going to write my 3x and my minus 2. I'm going to write my leading term, which is 27x cubed. And I'm going to write my final term, which is negative 9. And I'm going to remember my diagonals, which will add to positive 9x squared and negative 3x. So I asked myself, what times 3x will give me 27x cubed? And I know that that is 9x squared. 9x squared times 3x is 27x cubed. 9x squared times negative 2 is negative 18x squared. So if this is going to equal a positive 9x squared, and I have a negative 18x squared, then this will become a positive 27x squared, because 27x squared and negative 18x squared gives me positive 9x squared. So I ask, what times 3x will give me 27x squared? I know that that is a positive 9x, because 9x times 3x is 27x squared. 9x times negative 2 is negative 18x. Now, knowing that this is negative 18x, and when I add to this box I get negative 3x, that means that this box is 15x, because 15x and negative 18x add to negative 3x. So what times 3x gives me 15x? That is a positive 5. So positive 5 times 3x gives me 15x. Positive 5 times negative 2 gives me negative 10. Now, what you should notice right away, this negative 10 is not this negative 9. So I should have had negative 10, but I did have negative 9. So what I find myself asking is, what would I have to add or subtract to negative 10 to get negative 9? And I know that that is just adding 1. Negative 10 plus 1 gives me negative 9. So I am going to write this quotient as 9x squared plus 9x plus 5 plus 1 divided by 3x minus 2. Remember that we always want to take our remainder, which in this case was plus 1, and we want to put it as being divided by our divisor, which in this case was 3x minus 2. Just like when we were doing polynomial long division, we sometimes deal with problems where there is a term missing from the dividend. If we look at the three terms that we have here, this is x cubed, so there's my cubed term. There is no x squared term. That x squared term is missing. Here we have our x term, here we have our constant term. Now, what that means to me is that the little box with 4 subdivisions is not going to be enough, because here I would have an x cubed term, here I would have an x squared term, but I need another space for my x. So if I look back up at the previous example, x cubed term, x squared term, x term. So I need another box, so I'm going to add to this diagram one extra column. That way I can make sure that I have all the parts that I need. So again, I'm going to write my x, and I'm going to write my minus 2. I'm going to write my x cubed up here in the top. I'm going to write my minus 3 at the bottom right, and then I'll begin the problem. What times x gives me x cubed? That's x squared, which means minus 2x squared. Now, since I know that my x squared term is 0x squared, I know that what goes in this box has to just be the opposite of what I already found. So this is going to be a positive 2x squared, because positive 2x squared and negative 2x squared zero out. So what times x gives me 2x squared? That's 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. So negative 4x plus something gives me negative 5x. So that's negative 1x, because negative 1x plus negative 4x is negative 5x. And what times x gives me negative 1x? Negative 1. Negative 1 times negative 2 gives me positive 2. But again, I was supposed to have negative 3. So 2 plus or minus what gives me negative 3? And the answer to that is negative 5, because 2 minus 5 gives me negative 3. So when I write my quotient, I will say that it is x squared plus 2x minus 1 minus 5 over x minus 2. Now, there are two different ways that we can write this. I chose to put the negative signs in front of my 5 in front of the entire fraction. I could have written it as plus negative 5 over x minus 2, and it would mean the same thing. I just need to make sure that I'm only using the negative sign once and not putting it both in front of the fraction and in front of my number. On the back of our paper, we have 3 examples, and you'll notice this time that the boxes have not been drawn for you. So the big thing that we want to make sure that we're looking at is what is happening to the very first term in our dividend. Now, this is 2x squared, meaning that it has a power of 2, which says to me that I need 2 columns. You'll remember that the problems that we were just working on were all x cubed, and because they were x cubed, which is a power of 3, they needed 3 columns. So I'm going to write my 2x plus 7 down the left-hand side. I'm going to put my first term, which is 2x squared, in the top left. I'm going to put my minus 3, which is my second term, in the bottom right. And I remember that these two are going to add to a positive 2x. So I say, what times 2x gives me 2x squared? The answer is x. X times 2x is 2x squared. X times 7 is 7x. 7x plus negative 5x. 7x plus negative 5x will give me positive 2x. So I say, what times 2x gives me negative 5x? That one's a little rougher. What times 2x gives me negative 5x? Negative 5 halves. Negative 5 halves times 2x gives me negative 5x. Negative 5 halves times 7 gives me negative 35 halves, which is negative 17.5. Negative 17.5. But I was supposed to have negative 3. So what would I have to add to negative 17.5 to get negative 3? I would have to add 14.5. Because negative 17.5 plus 14.5 gives me negative 3. So when I write my quotient, I'm going to say it is x minus 5 halves. I might write that as 2.5 plus 14.5 over 2x plus 7. Looking at my second example, again, I see that it is an x squared term, meaning I only need 2 columns. So here are my two columns and my two rows. So this is x minus 1. I'm going to write my 2x squared here. I'm going to write my plus 2 down here. What times x gives me 2x squared? 2x. 2x times x is 2x squared. 2x times 1 is negative 2x. Now I'm trying to get negative 4x. So this is negative 2x plus negative 2x. Because negative 2x and negative 2x gives me negative 4x. What times x gives me negative 2x? The answer to that is negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2, so that is exactly what I was expecting, meaning that my quotient this time will not have a remainder, 2x minus 2. And one final example. Again, this is an x squared term, meaning I only need two columns. So here are my two columns and my two rows. I'm going to write the x plus 2 down the side. Top left, I'm going to put 3x squared. Bottom right, I'm going to put negative 2. What times x gives me 3x squared? The answer is 3x. So 3x times x is 3x squared. 3x times 2 is 6x. But I don't want 6x. I want 5x. So this box is going to be negative 1x, so that way negative 1x plus 6x gives me 5x. What times x will give me negative 1x? The answer is negative 1. Negative 1 times x is negative 1x. Negative 1 times 2 is negative 2, which is what I wanted. So when I write my quotient, I will say that it is 3x minus 1. Now remember, there is the space at the bottom for your note summary. Something to think about, this says using the area model for polynomial division is useful because, and also, as always, we have space. So if you have any questions or comments, make sure you jot them down so that way you can ask them the next time you're in class.